Right now, nearly 7 out of every 10 new ships ordered anywhere on the planet are going straight to Chinese shipyard. Not a slight edge. A near-total takeover of an entire global industry, happening quietly while most people were looking somewhere else entirely. We're talking about vessels so massive that 3 football fields could fit inside their length, ships that in a single voyage can carry enough crude oil to cover roughly 10% of America's entire daily oil consumption. One ship, one trip, and by the time you finish this video, you'll understand why building these ships isn't really about selling steel, it's about controlling how energy physically moves around the entire world. Let's rewind for a second. Shipbuilding used to be split 3 ways. Japan had decades of precision craftsmanship. South Korea had speed and cutting-edge tech. China had raw scale, endless steel, and a workforce that never stopped growing. For years, that balance felt stable. 3 major players meant no single country held all the cards. Then China didn't just get better at the existing game, it rebuilt the entire system from the ground up. New factories, new financing models, new construction methods, all pointed at one target: build more ships, faster and cheaper than anyone else on Earth. By 2025, that strategy had paid off in staggering fashion. Chinese shipyards produced 53.69 million deadweight tons of vessels that year alone, an increase of over 11% from the year before, and enough to account for roughly 56% of everything built globally. Meanwhile, new orders told an even bigger story about the future, with China capturing close to 69% of all new ship orders placed worldwide. That's not just dominance today. That's a preview of the ships that will still be sailing in 2050, all being designed and built in China right now. To understand why this matters so much, you need to understand what these ships actually are. A very large crude carrier, known in the industry as a VLCC, stretches around 330 meters long, wider than a football field laid sideways, and can hold close to 2 million barrels of crude oil in a single trip. The steel alone going into one of these ships weighs roughly 55,000 tons, and every weld across that mass of metal has to survive 25 to 30 years of brutal ocean punishment, crushing waves, shifting cargo, relentless pressure. And somehow, Chinese shipyards can now take one of these from raw steel to a fully seaworthy vessel in under 2 years. Here's how. Instead of building top to bottom the old way, engineers now slice the entire ship into more than 100 separate sections, each weighing between 300 and 600 tons, building them all simultaneously before craning them together like an enormous puzzle. This is called modular construction, and it's only possible because of a staggering layer of technology underneath it. Across the biggest Chinese shipyards, millions of sensors feed real-time data into AI systems that catch alignment errors as small as the width of a human hair, because a tiny mistake early on can snowball into a structural failure by the time you're 100 sections in. Even the welding has largely been handed over to robotic arms capable of running at the exact same pressure and temperature for days without fatigue, something no human welder, however skilled, can consistently match. Then there's the engine, essentially a 4-story building's worth of machinery generating close to 100,000 horsepower, driving a single-piece propeller that weighs over 100 tons. Improving that propeller's efficiency by just 1% can save up to $1.5 million in fuel per ship, per year. Multiply that across a fleet running for 30 years, and you start to see why every fraction of a percent matters this much to shipping companies. Now look at what's coming next. Newer Chinese tankers are pushing even further, some fitted with 40-meter rigid sails built from carbon fiber that capture wind energy and cut fuel use by nearly 10%. Others run on dual fuel systems that can switch between diesel and liquefied natural gas, slashing carbon emissions by around 20% and sulfur output by as much as 85%. And critically, these newer vessels are being built to last 30 years instead of the traditional 25, which for a fleet operator translates into hundreds of millions of dollars in added long-term value. But here's what most coverage completely misses. The real power isn't in the steel, the sails, or the engines. It's in what all of this represents for global energy flow. Around 60% of all the oil traded worldwide moves by sea, not pipeline, not rail, by ship, and the overwhelming majority of those ships were built in China. When a shipping company takes delivery of a Chinese-built tanker, that relationship doesn't end at the sale. Spare parts, maintenance, software, technical support, all of it flows back to China for the ship's entire operational life. And Chinese state-owned banks made ordering these ships even easier by offering financing that spreads out the massive upfront cost, which is exactly why companies from Greece, Norway, and across Asia keep placing bigger orders year after year. For most of modern history, energy power belonged to countries with oil in the ground. But oil doesn't move without ships, and ships don't exist without shipyards. So when one country builds the vessels carrying 60% of the world's oil trade, finances them, and maintains them for 30 years at a stretch, it holds a form of quiet influence over global energy that doesn't require owning a single oil well. The ships being built today will still be sailing in 2055, long after most of today's headlines are forgotten, and that infrastructure will keep shaping how energy moves across this planet for decades to come.